right, welcome to class, everybody. If you didn't grab your tests already, you can come up and grab it real quick. And our lesson today is about factoring. So we'll get started on that in just a second, but I want to go over a couple questions on the test that a lot of people missed, just to kind of review those concepts. So the first one is number 3. And on this one, to start off solving it, you would distribute to get rid of the parentheses, which would give you this expression. And when you combine like terms and you do 15x minus 2x, you get 13x, negative 20 plus 6 gives you negative 14. And once you get to this step, you could, if you wanted to, subtract 13x to eliminate one of the x's on each side. But it would actually end up eliminating both of them. And you would end up with negative 14 equals negative 14, which is a true statement. And that tells us, like, if both of your variables get eliminated, and you get a true statement, that means there's an infinite number of solutions. It's a little bit easier, I think, to see it at this stage, because no matter what x is, like, you could plug in any number for x and it would make that statement true. And so the correct answer on number 3 was that there's an infinite number of solutions. Another one that a couple people missed was number 7. This was the absolute value one within an equality. So your first step is to get rid of the absolute values by saying, okay, well, the stuff inside the absolute value, if it has to be less than 9, then that means that it can either be less than 9, but it also has to be greater than negative 9, because if it was like negative 10 or something like that, the absolute value of negative 10 would not be less than 9. So you say, okay, well, that stuff has to be in between negative 9 and 9, and then you add 7 to all the parts, divide by 2, and you end up with x's in between negative 1 and 8. And on the number line, that would look like an open circle at 8, an open circle at negative 1, and you shade all the space in between it. So that's number 7. And then on number 11, this one was the one where they gave you 2 points, they gave you 2 lines, and on each line, they told you 2 of the points that were on the line. So you have these 2 black points and the 2 red points, and you are asked to determine whether or not the lines are parallel, perpendicular, or neither. So the way you determine that is you calculate the slope of the lines. So the slope of the black line, if you use the slope formula, would end up being 2. The slope of the red line would be 1/2. And in order to be parallel, they have to be the same. So they're definitely not parallel. And to be perpendicular, they have to be opposite reciprocals of each other. And these are reciprocals of each other, but they're not opposite. And this is a little bit more obvious that they're not perpendicular if you graph it, because if you go like 1, 9, negative 2, 3, that'd be about right there. So you've got this line for the black line. And then for the red line, you have 5, 4, which is going to be approximately here. And 3, 3 is right here. Again, that's just like a really rough sketch. You can kind of see that they're obviously not parallel, and they're also not perpendicular. And the reason why they're not perpendicular is because one of them would have to be negative in order to be perpendicular. So that's number 11. And those are the main ones I wanted to go over, because there are several people who missed those. But if you missed any other questions and you would like to understand what the correct way to solve them is, just let me know during homework time and I can answer any of those questions for you. All right, so let's jump into our lesson for today, which is factoring the greatest common factor and factoring by grouping. So first of all, let's talk about what a factor is. So a factor is something that is multiplied together to get the product. So if you were looking at factors of 24, you might say, well, some of the factors of 24 are 4 and 6, because 4 times 6 equals 24. And when we factor something, you can do, it's possible to have it partially factored. So what I mean by that, if we take the number 24, 24 can be factored into 4 times 6. But 4 can be factored into 2 times 2, and 6 can be factored into 2 times 3. And so the complete factorization of 24 would be 2 times 2 times 2 times 3, because you can't break those factors down any further. This is still a factorization of 24 though, because 4 times 6 does equal 24, but this would be a completely factored version of the number 24. So what we're going to be working on today is we're going to take polynomials and we're going to factor them. So our goal is, instead of having a number and breaking it down into things that are multiplied, we're going to have a polynomial and we're going to break it down into smaller polynomials that can multiply together to equal that polynomial. So that's kind of the goal of factoring. Just kind of as a review of like the structure of how equations or math sentences are created, terms are things that are added together, or you could also have them subtracted. So terms are added together, factors are multiplied together. And the goal of factoring is to take a bunch of terms, so like a polynomial, and to factor it so that you have two things that are multiplied together. Because the structure of this, if we look at it, we have 3 terms here. And inside of the terms, you also, inside of the terms, you also have some multiplication, like you have 6 times 2 x's and 7 times x. But the general structure of this side is that they're like you've got things that are being added together. On this side, though, the general structure is that you have 2 things that are multiplied together, and then inside of that, you have things that are added together. So the goal of factoring is to take a bunch of things that are added together and convert it into a form where they're multiplied together. So we're going to use what we've already talked about with multiplying polynomials to help us build some understanding of how this would work. Because we already know how to get from here to here, right? You would just FOIL or multiple distribute, however you want to think about it. You go 2x times 3x gives you the 6x squared. 2x times 5 gives you 5x, but then you also have negative 3x from multiplying these two, so that gives you the 7x. And then negative 1 times 5 gives you negative 5. So we know how to get from here to here, and so we're essentially just reversing that process. So let's start with the easiest type of factoring, which is factoring the greatest common factor. So factoring out the greatest common factor is basically the reverse of distributing. So if we had an expression like this, and we were asked to turn it into a polynomial that wasn't in factored form, we would distribute the 4 to all 3 terms inside parentheses, right? This is stuff we've done already. And we would end up with this result. So what we're doing today is we're essentially undoing that distributing. And the way we do that is we look at all of our terms and we say, what factors do they have in common? Or in other words, what can they all be divided by? So in this case, what can 12x squared, negative 20x, and 4 all be divided by? 4. So that's going to be my greatest common factor. And when I factor it out, I basically divide it out of each term. So 12x squared divided by 4 would give me 3x squared. Negative 20x divided by 4 would be negative 5x. And 4 divided by 4 is positive 1. And you can see what I did was I took this and I turned it into a factored form. And you can see it's the same as this. But I could have done that even if I hadn't had this piece of information. Is everybody good with that? Okay, so why don't you guys go ahead and practice this one. Factor out the greatest common factor in your notebooks, and then I'll show you how I would do it. All right, so when we look at this one, we have 3 terms that are being added or subtracted together. And when I look at those 3 terms, what do they all have in common? They all have a what? Yep, they have a 5. Is there any bigger number that they also have in common? What would it be? Yep, 25. They would all have that in common. Is there any bigger number? Anything bigger than 25?
25y squared x.
Perfect. Yep. So the number wise, 25 is the only number that they can all be divided by, right? Or it's the biggest number, I guess I should say, because they can also all be divided by 5, but you want to find the greatest common factor to be able to fully factor it. So 25 is the greatest number. And then, like you said, we also have an x in common and 2 y's in common, because every single term has at least one x and 2 y's. So that's going to be our greatest common factor. And when I take my first term and I divide by this, well, 150 divided by 25 is 6. X cubed divided by x is x squared. Y squared divided by y squared just cancels out. Then for my next term, positive 75 divided by 25 gives me positive 3. X divided by x cancels out. Y squared divided by y squared cancels out. And so that term would just be a positive 3. And then for this one, if I have negative 100 divided by 25, I get negative 4. X squared divided by x is x, and y squared divided by y squared cancels out. And so this would be my factored version of this polynomial. And you can always check your work by saying, if you distributed this, would you get what they originally gave you? Because the whole goal of factoring is to undo distributing. Yeah.
So could you just do 25 and then finish it from there and then combine like terms on the inside?
So you wouldn't actually end up with any like terms on the inside, because if you did that, you'd have 25 times 6x cubed y squared plus 3xy squared minus 4x squared y squared, like that. But none of these are like terms, because this one has 3 x's and 2 y's, but this one has 1 x and 2 y's, and this has 2 x's and 2 y's. And so you couldn't combine them since they're actually not like terms. If they are like terms, though, you can actually combine them even before you start, and that would work. Any other questions? Well, they always what? Sometimes they don't, in which case we're going to learn some other tools for factoring. Because if you think about, like, essentially we're undoing multiplication of polynomials, and this is not the only type of multiplication there is. There's also foiling and those types of things. And so we'll learn other tricks for undoing those. Yeah, but this is like a good starting place to start building the concepts. All right, let's do a check-in. So scale of 1 to 5, how are you guys feeling about factoring out the greatest common factor? Okay, awesome. So let's move on to our second topic for the day, which is factoring by grouping. So factoring by grouping is the way that we're going to undo multiplication of binomials, or technically you can do trinomials and stuff like that as well. So the idea of factoring by grouping is we're going to undo the process we would do when we multiply them. So we don't usually write these steps out, but it is helpful for factoring by grouping to think about it this way. So the way that we figure out that these two polynomials multiplied together equals this is we start out by doing 3x times 2x and 3x times 5 and negative 4 times 2x and negative 4 times 5, right? Or you could call it foiling or whatever method you like to use, but that's essentially what we do to get this. So we don't usually write it this way, but this blue part is essentially doing 3x times the other polynomial, right? We don't really ever write it out like that, but that's what it's doing. And then when we multiply the negative 4 with the red stuff, we're basically doing negative 4 times the other polynomial. So it's kind of like we do this double distributing thing. So we distribute each of these terms to this polynomial. So, and then, you know, you distribute that and you simplify it out and you end up with this, right? And then ultimately we end up combining these two terms together to get the 7x. So factoring by grouping basically takes it from this step and goes backwards. So the way that factoring by grouping works is I would take this polynomial and I'm going to split it into two groups. And you do this when they don't have anything in common. So like if we look at these, like this entire expression, none of these terms all share the same thing. Like some of them share some things like -8 and 6. You could divide both of those by 2. You could also divide 20 by 2, but you can't divide 15 by 2, right? So we do what's called factoring by grouping, where we split it up into 2 groups and we factor the groups separately. So if I look at just this group, those 2 things do have things in common. Specifically, what are they? Yep, we've got a 3. Is there anything else we have in common? Yep, we also have an X. Is there anything else they have in common? Nope. So I'm going to factor that 3x out, and that gives me 2x plus 5 for the first group. Then for my second group, I'm going to factor this out. And what does -8x and -20 have in common? Yep, they have a 4, and we're going to actually do a -4 because you could also say they have a -4 in common. And that leaves 2x plus 5 because 8x divided by -8x divided by -4 is positive 2x. -20 divided by -4 is positive 5. Okay, so do you guys see how I got from here? Because this is the same thing as this. So if you were given this, you could get back to this step with this factoring by grouping that I just did. Now, once you get it to this step, the structure of your equation or your expression in this case is that you have 2 things that are added together, or in this case, subtracted. Does everybody see that? How there's only 2 things? And then like within those things, you have multiplication of -4 times the parentheses stuff. And inside the parentheses stuff, you have things added. So it's a rather complicated 2 things that you're adding together. But at the core, you only have 2 terms. And so you look at those 2 terms and you say, well, do those have anything in common? Well, yes, they have a 2x plus 5 in parentheses. And so that is now our common factor. So we factor that out. And if I divide this first term by 2x plus 5, I'm left with 3x. If I take the second term and divide the entire thing by 2x plus 5, I'm left with -4. And so I have 3x minus 4 as my factored form. And you can see that's basically what we got here. I just wrote the factors in a different order. Any questions on that?
Yeah, can you go back to that bottom?
This part right here?
Yeah, I think that's good. How did you get that?
Yeah, so does it make sense how we have 2 terms?
Yes.
And so if we look at those 2 terms, they have 2x plus 5 in common. So we're going to pull that out. Just like here where we had a 6x or 3x in common, how we pulled the 3x out, we're going to pull out this. So it's a rather complicated common factor, but that's what we pull out. And when I do this term and I divide by that common factor, I have 3x. Because if I take this and divide by 2x plus 5, the 2x plus 5s cancel out, and I'm left with 3x. And then same thing here, I divide this by 2x plus 5, and I'm left with a -4. So it's almost kind of like you treat like all of the parentheses stuff that matches, like just like a single thing. So it might be easier if you kind of think about it as like 3xz minus 4z. Well, if you were factoring that, you just pull the z out. But in this case, rather than having z, you have this complicated expression.
Oh, so how is it like in the fully factored, like 2x minus 5?
Mm-hmm.
Like how does like the plus 5 become like a minus 5?
Oh, it should be plus 5.
Oh,
Sorry. Thank you. Yeah. They just magically switch. Sorry, that was my fault. Okay, let's go through another example so that you guys can see another example of how this works from start to finish. So when we look at this polynomial, there's nothing that they all have in common, right? Like these 2 terms have b's in common, these have a's in common, these have 8's, but there's nothing that all of them have in common. So that tells us that we're going to need to do factoring by grouping. So I'm going to split them up into 2 groups. And what does the first group have in common? b squared. So I'm going to factor out b squared, and I'm left with a squared plus 1 when I divide both of those terms by b squared. And the 1 is important. Don't just like put nothing there. It is important that when you do b squared divided by b squared, you get that 1 there. Okay, now in the second group, what does the second group have in common? Yep, it has a plus 8. And when I factor that out, I also get a squared plus 1. And so because a squared divided by 8 is a squared, and 8 divided by 8 is 1. Now, because I have two things that are being added together, and these two things have something in common, I can factor out the thing they have in common. So I'm going to factor out a squared plus 1. And when I take this term and divide by a squared plus 1, the a squared plus 1s cancel out, and I'm just left with b squared. When I take this term and divide by a squared plus 1, I'm left with positive 8. And again, I'm kind of just thinking about this as being like its own, like it's just a thing. Like I'm not really worried about like the fact that it's squared or plus 1 or anything in there. I'm just noticing that this is the same as this. So in my head, I'm kind of almost thinking about it as like b squared, I don't know, let's just call it x plus 8x. I'm kind of almost thinking about it as factoring something like this. It's just, it's not a single letter. It's this complicated thing. But the important thing is that these two match. If they don't match, then you can't factor them out because they're not the same factor. Or the same factor. Which, let me actually go back to this one. So on this one, you know how at this stage we factored out a -4? If you had factored out a +4, you would have got -2x minus 5. And in that case, those wouldn't have matched. And so when you're factoring at like this level, make sure that you factor it in a way that the stuff in the parentheses will match. Because if they don't match, you can't pull out those common factors. Okay, do you guys feel ready to try an example on your own? Okay, this one had a typo. I think it's this. This should be a y squared, not a y to the 4th. Bring it back. I think she just maybe picked up someone else's.
Okay.
Yeah. Okay, so on this one, since there's nothing that they all have in common, I'm going to split them up into two groups. If they do have anything in common, pull that out first and then factor the remaining stuff after that point. But in this situation, we didn't have anything in common, so I'm going to split it into two groups. And the first group has an x to the 4th in common, which leaves me with y squared plus 2. And then the second group has a 2 in common, which also leaves me with a y squared plus 2. So that's good that my parentheses stuff is matching, because that means that I now have common factors between these two terms. And I can pull out that common factor of y squared plus 2, which leaves me with x to the 4th plus 2 when I divide that out. And so that would be the factored form of this polynomial. Let's do a check-in scale of 1 to 5. How do you guys feel about that? Okay. So there's also, it doesn't matter, well, okay, it matters to some degree, but in some cases, it doesn't matter how you group them. So in this example, I just grouped them based on the way they were written. But with addition and subtraction, you can rearrange it in whatever order you want. So like it could have been written x to the fourth y squared plus 2y squared plus 2x to the fourth plus 4. So essentially, I just switched the order of those two middle terms. This will still work for factoring by grouping though, because if I split it into two groups, that first group has a y squared in common, which leaves me with x to the fourth plus 2. The second group has a 2 in common, which leaves me with x to the fourth plus 2. And both of those parentheses stuff, those are the same thing. And so I could factor that out and I get x to the fourth plus 2 times y squared plus 2. And you can see you end up with the same answer in both cases, but the way you got there was different. Like in this case, the stuff that ended up in parentheses was y squared plus 2, versus here it was the x to the fourth plus 2. So if you ever run into a problem where you can't factor by grouping, just like you can try rearranging the terms and see if the rearrangement makes it so that you can do factoring by grouping. Because some arrangements will work and some don't, and there's often multiple arrangements that will work. But not everyone will, like, because if I had switched like let's say I'd switched the 4 and the 2x to the fourth, well, x to the fourth y squared, and if I had a 4 here, those don't have anything in common. So if you ever can't do factoring by grouping, just try rearranging the terms, and sometimes that will make it so it is possible. Let's see, I think there's one more thing I wanted to say. Oh, on your homework, there's problems that look like this, and the instructions say to factor out the greatest common factor, which, I mean, technically it is an accurate instruction because you have two terms and you look at which one they have in common. So in this case, they have an x minus 3 in common, and the stuff that would be left over is that. But I don't particularly like those instructions very much because essentially what they're giving you is like the halfway point for factoring by grouping, and they're asking you to finish it. So if you see a problem like this that has like parentheses that match, basically they've done part of the factoring by grouping for you, but it's not all the way finished yet. Because what the original problem would look like would be 2x cubed minus 6x squared plus 5x minus 15. And they've basically like grouped it and factored the first step, but you have to continue doing the factoring by grouping. So if you see any problems like that on your homework, that's what they're because like the order of your homework, they start off with the easy ones we started with, where you're just reverse distributing a single term. And then they move on to problems like this, and then they go into factoring by grouping. So the structure of your homework is to kind of like lead you from easiest to hardest. But I don't personally think it, like this is the middle step, but I think it's easier if you know the entire process rather than just building it from the middle step. So yeah, that's the stuff on your homework. You should be able to do everything on your homework from here. I think there was, I can't remember if it happens on every problem, but if you ever have something that's like, hopefully I can make up one that actually factors well. If you ever end up with something that's like that, when you split it into two groups, like obviously the first one has an x squared in common, and you would have y plus 1. But the second one doesn't have anything in common, but we can still factor out a greatest common factor. That's just going to be 1. So it's not a very big common factor, but you can still factor out a 1, which leaves you with y plus 1 in parentheses. So if you ever don't have something in common, just say that the greatest common factor is a 1, because 1 times anything will still be itself. Okay, so now I think you're ready to go. So if you have any questions, let me know. And I can also answer any questions you guys had on the tests if you'd like clarification on that.